In this video, I want to discuss the negative binomial distribution. The negative binomial distribution is very similar to the geometric distribution. The geometric distribution looked at independent Bernoulli trials performed until the first occurrence of a success, and negative binomial looks for the rth occurrence of a success. So we might want the second success, the third, or the 20th success. X is going to be the number of trials up to and including the rth success. And once again, our probability of success is p. Let's start with the probability mass function. My probability mass function is given by the probability that my random variable x is equal to some value of little x is x minus 1 c r minus 1, p to the r, 1 minus p to the x minus r. So this p to the r, we need r total successes. So I'm going to multiply p by itself r times. This 1 minus p to the x minus r, the rest need to be failures. And this term out front, this x minus 1 c r minus 1, counts all of the different possible combinations for the first r minus 1 successes. We know the rth one has to be last, but we haven't said anything about the previous ones. The expected value of this random variable is just r over p. And the variance is r times 1 minus p over p squared. So both expected value and variance is just r times the expected value or variance of a geometric distribution. So let's look at some examples. Let's suppose items are being inspected as they come off the production line until the third defective item is found. We're going to let x denote the number of non-defective items found. If an item is defective with a probability of p equal to 0.1, independent of other items, I want to find the mean value and the variance of x, as well as the probability that x is equal to 15. In this case, we're looking for the third defective found, so 3 would be my value of r. My p-value is 0.1. So my expected value would be equal to r over p, 3 over 0.1, which is 30. So we should expect to get about 30 items before we find the third defective item. The variance is r times 1 minus p divided by p squared. And this works out to be 270, so the variance here is 270. Finally, we want the probability that x is equal to 15. So we do this as 15 minus 1, choose 3 minus 1, p to the r, 1 minus p to the 15 minus r, so 15 minus 3 is 12. So we need 3 successes, we need 12 failures, and we don't know where the first 2 defective items are found. We have the first 14 items, we need to pick 2 of them to be the first 2 defective items, which works out to approximately 0.0257. Let's suppose we have 2 athletic teams, which we'll call A and B, and they're going to play a best of 3 series of games. So in other words, the first team to win 2 games is the overall winner. We're going to suppose Team A is the stronger team and will win any game with a probability of 0.6, independently from other games. I want to find the probability that the stronger team will be the overall winner. This is a negative binomial distribution. We have a probability of 0.6. And we need to win 2 out of 3 games. Well, there are 2 ways that could happen. We could win the first 2 games and be done, or we could win on the 3rd game. So we could win 1 and lose 1 in whatever order, and then win the 3rd. The probability that x is equal to 2. The probability that x is equal to 2 is a little bit easier. We need to win the first game and win the second. So 0.36 chance that Team A wins within the first 2 games. For the first 3, well, we still need to win 2 games, but this time we're going to lose 1. And whether we win the first or win the second gives me that we have a total of 2 games that we need to pick one of for which one we lose in, which works out to 0.288. And since I only need one of these things to be true, I just add these up to get a total of 0.648. So there's a 0.648 chance that Team A will win this tournament.